It begins as bent copper, stamped metal, and a fluid that boils below freezing, and ends as the wave of cool air that saves you on the hottest day of summer. This is how an air conditioner is made. Walk into a cool room on a brutally hot day, and it honestly feels like magic. But here's the strange truth. Your air conditioner doesn't actually make cold air. It grabs the heat already floating around your room and quietly throws it outside. That single idea is the secret the entire machine is built around. So let's take a home air conditioner apart, piece by piece, and see how it's really made. Most homes today use what's called a split system. One slim, quiet unit lives inside on your wall, and one bigger unit hums away outside. The two are joined by thin copper pipes carrying a special fluid called refrigerant. That fluid is the real worker. It soaks up heat indoors and dumps it outdoors, over and over. The first modern unit was built in 1902, not for people, but to stop paper from wrinkling in a printing plant. To really understand the machine, you have to follow that fluid through every part. And it all starts with three humble materials: copper, aluminum, and steel. Long copper tubes arrive coiled into giant rolls, ready to carry the refrigerant. Thin aluminum sheets arrive in heavy spools, waiting to become fins. And rolls of steel arrive to form the tough housings that hold everything together. Copper and aluminum aren't random. They pull heat in and let it go faster than almost any cheap metal. The true heart of an air conditioner is its heat exchangers, which everyone simply calls the coils. First, machines cut and bend the copper tubes into long U-shapes called hairpins. At the same time, a stamping press punches the aluminum into thousands of thin, slotted fins. The press hammers out these fins so fast, your eyes genuinely cannot keep up. Each fin has a tiny raised collar around its holes, so the tubes will fit snugly through them. Machines stack these fins into a dense block, packed tightly together like pages in a book. Then, the copper hairpins are pushed straight through the whole stack of fins. At this stage, it looks like a giant metal comb, skewered onto rows of copper rods. Now comes a clever trick. A steel rod is forced down through each copper tube to expand it. As the copper swells outward, it presses tight against every single fin, locking them together. Now heat can race out of the tube and into hundreds of fins at the very same moment. The open ends of the hairpins are joined with small U-shaped bends to make one long winding path. Every joint is sealed shut with a torch in a careful process called brazing. The finished coil squeezes meters of copper tube and a whole forest of fins into one small frame. Now for the part everyone calls the heart of the machine, the compressor. It lives in the outdoor unit and works like a powerful pump for the refrigerant. Inside its heavy steel shell, an electric motor spins a tight scroll or a small piston. This squeezes the refrigerant gas, shoving its pressure and its temperature way up. The whole compressor is then welded shut and sealed for life, never to be opened again. If this heart ever fails, you replace the entire organ. You don't repair it. Here is the cycle that every part of the machine is built to serve. The compressor pushes hot, high-pressure gas into the outdoor coil. A fan blows air across the fins, and the gas cools into a liquid, dumping its heat into the outside world. That liquid then squeezes through a tiny valve, and its pressure suddenly collapses. The instant the pressure drops, the refrigerant turns shockingly cold, far below freezing. This is the fluid that boils colder than a freezing winter night. The icy liquid flows into the indoor coil, while a fan pulls your warm room air across it. The refrigerant drinks up that heat, your room cools down, and the fluid boils back into a gas. That warm gas travels back to the compressor, and the entire loop begins all over again. Modern units use newer refrigerants, like R32, chosen to be gentler on the planet. Moving all that air around takes two very different fans. The outdoor unit uses a wide propeller fan to shove unwanted heat out into the open air. The indoor unit hides a long barrel-shaped roller called a cross-flow fan. It sweeps a smooth, quiet sheet of cool air gently across your whole room. All of these delicate parts need strong, rust-proof bodies to live inside. Steel sheets are stamped, bent, and punched into sturdy base pans and side panels. The bare metal is cleaned, then coated with baked-on powder paint to fight rust and weather. The indoor unit gets its smooth white cover, shaped in a hot plastic injection mold. Then comes the brain of the whole system, the control board. Tiny sensors, a microchip, and an inverter are soldered onto a green circuit board. The inverter lets the compressor gently speed up or slow down, instead of just clicking on and off. That's exactly why a modern unit sips electricity instead of gulping it down. Now, on the assembly line, everything finally starts to come together. In the outdoor unit, the heavy compressor is bolted firmly onto the steel base pan. The big condenser coil is wrapped around the inside walls like a metal fence. Then the propeller fan, the control box, and all the copper pipes are connected by hand. In the indoor unit, the slim evaporator coil sits tucked behind the front grille. The cross-flow fan, a water drip tray, and washable dust filters all slot in around it. The control board and sensors are wired in, and the smooth plastic cover snaps on top. But before it can cool a single room, the system has to be filled with refrigerant. First, a machine sucks out all the air and moisture, creating a deep vacuum inside the pipes. Then, the exact amount of refrigerant is injected, and it's measured right down to the gram. A few grams too much or too little, and the whole unit cools weakly or strains itself. Every sealed joint is then hunted for leaks, often using incredibly sensitive detectors. Finally, each finished unit is switched on for a full, real-world run test. Technicians measure its cooling power, its noise, its vibration, and its energy use. Any unit that runs too loud, too weak, or too thirsty gets pulled straight off the line. Only after passing every single test is a unit wiped down, boxed up, and labeled. It ships out as a matched pair, the indoor unit and its outdoor partner, made for each other. Later, an installer joins the two with copper lines and finally lets the refrigerant flow. From bent copper and stamped fins to a sealed, humming machine, that is the whole journey. So next time cool air rescues your summer, remember, it's really just heat, packed up and shown the door. And now you know exactly how it's made. Now it's your turn. What should we build next? Drop it in the comments. The most liked idea becomes our next video. See you there.